what you have to do, you have to, as I just mentioned, you have to use your general knowledge of math. So here you know that any number, anything raised to the power of 0 would be equal to 1. So basically x could be anything. Okay, let's continue with some simple logarithmic equation. Here you have logarithm and you're supposed to find the x. So your best bet would be converting it to, yes, exactly, exponential. 2 to the power x equals 16. So remember 16 is 2 to the power 4. So here, from here, it's one step, you could see x is equal to 4. Let's do another example. Again, here you have to change it to convert it to exponential. So 27 is 3 to the power 3, x to the power 3. So from here, x is equal to 3. These are very simple one-step equations, which are which are needed to do more advanced, examples afterwards. So next one is x 5 to the power 3, which is 125. So x is 125. Now next one, again, you do the same thing, but here calculation is a little bit more, difficult. So 32 to the power 4/5. What you can do here, you can go like this. You could say 32 raised to the power 1/5, then raised to the power 4. This is how you can use it. So I just put it as a side note that 32 is 2 to the power 5, right? So 2 to the power 5, and then you raise it to 1/5. That would be 2. So the answer is 2. 2 to the power 4, right? So your answer is 16. Let's do another two equation here. Again, we change it to exponent. 3 to the power 4, it's 5x plus 1. From here, we know that 81 is equal to 5x plus 1. So 5x is equal to 80. And then it's a linear equation, so your x is 16. Now, the next question is log x equal 24. This one, you can see that here there is no base, but what you know that whenever the base is not there, it's 10. So you could say 10 to power 24 is equal to x. Now let's do another example. Okay, this is another example. Here you have 1 log equal to a constant. Again, what you have to do, your best bet would be changing it to exponent. So again, x2 plus 3x plus 9. Okay, so from here, you just simplify. This would be 49. You move it to this side, it would be minus 40. So you're looking for two numbers. If you add them, you get 3. And multiply them, you get negative 40. So your answer would be either negative 8 or what is the other answer? Is 5, right? So your answer is either negative 8 or 5. Next one, it's an ln. Again, you convert it into exponential. So you would see e to the power 5 is 3x minus 2. Okay, so e to the power 5 plus 2 divided by 3 is your x. And you can find the exact value using your calculator, right? Maybe to 2 decimal places, which is equal to 50.14. Now the next one that I'm gonna give it to you is 4 times ln 2x minus 1 plus 3. It's equal to 11. So remember, like any other equation, the first step is try to make it as simple as possible, and then trying to convert it to other form like linear or quadratic equation or other forms. Okay, now let's see what I can do. Here I have this thing to the power 2 minus 36. Remember guys, the base is 3, but here I have 20 times. So this 20 will come into the, in front, and then I will see a nice pattern. So I would have And then I would have, let's see, log x to the base 3 to the power 2 minus 36 minus, I will move this one to the other side, 20 times log x to the power to the base 3. So from here, as you can see, you have something to the power 2, something to the power 1, and then a constant. And what does it remind you of? Yes, it reminds you of, let's say, quadratic. So wherever you see log x to the base 3, you can replace it with w, okay? So w, okay? So I wouldn't use x because it would be confusing. So here I will go w squared minus 20w minus 36 is equal to 0. So you would have to solve this quadratic equation. You can either use factorization or quadratic formula. So we are looking for two numbers. If we add them together, we get negative 20. And if we multiply them together, we get negative 36. Okay, guys, there was a mistake here. So it should have been plus 36. So we're looking for two numbers. If we add them, we get negative 20. And if we multiply them, we get 36. So these are the two numbers. From here, your first answer would be w equal to 2. The second one would be 18. Okay? Now, you found w. From w, you have to calculate the x. Okay, so let's do it this way. W equals 2 equals log x to the base 3, right? Because the purpose is to find the x. From here, you can change it from logarithm to exponent, okay? So if we use the formula, 3 to the power 2 would be equal to x. Now the other w is 18, which is also equal to log x to the base 3. So here, 3 to the power 18 would be x. So your final answer, which is x, is 3 to the power 2 and 3 to the power 18. These are your two answers. This is another question, but this time I'm using the natural logarithm. Here, what you have to pay attention, it is natural logarithm, and you have two options. The first option is either to use the quotient rule, or the other option is to move one of the ln to the other side of the equation and equate the this part to this part. I'll try to solve it from both ways, so you would have an idea of different methods of solving. So here, let's start with method 1, which I'm going to use the quotient rule, okay? So here, ln x2 minus 15 divided by 2x is equal to 0. And remember, ln is exactly the same as logarithm. The only difference is that the base is e. So remember, guys, this is the base, which is e. So from here, if I use the conversion, it would be e to the power 0, which is 1, equals to x squared minus 15 over 2x, right? From here, we have to solve it and, get the value. What do? We go cross multiplication. 2x equals x squared minus 15. So x squared minus 15 minus 2x equals 0. So I'm looking for two numbers. If I add them, I get negative 2. And if I multiply them, I get 3, right? These negative 50. So now one answer is 5. One answer is negative 3. Okay, so this was method 1. Let's use the other method here. So method 2, okay, so it's up to you. As long as you get the correct answer, it's fine. So method 2 is moving one of the ln's to the other side. So that would be ln 2x. As you can see here, I have one ln here, one ln here. Both of them have got the same base. So that means the two parts here must be equal to one another, right? Which would be x squared minus 15 equals to 2x. If I rearrange it, it will come up to x squared minus 2x minus 15, which is exactly the same as the equation here. So no matter what method you use, the answer must be exact. Okay, now let's move on to the next equation. This is a very big chunky equation, but as always, we start with simplification. So here you can use any of the rules. I cannot do anything with this 2 because this 2 belongs to the whole thing, right? So I cannot move it to the front. It is not possible. But this -1, you can easily move it to the front. But what I can do here, I can replace log x to the base 5 with w, right? So if I want to simplify it, this will be w to the power 2. This -1 will be multiplied by -2, so that would be 2w minus 3. From here, I have a very simple factorization to do. Looking for two numbers, if I add them, I get 3 plus 2. If I multiply them, I get -1. So one answer is -3. One answer would be +1. But remember, guys, this is w. From w, you have to get to, yes, x. So log x. All right. And the other one is log x to the base 5. All right. So here, x would be 5 to the power -3. And from here, x would be 5 to the power 1. Okay, this is another big equation in logarithm. But remember, guys, it's also very easy to do. Here, again, you have two methods of solving it, right? What I'll do, I will use the product rule. Okay, so here, if you have one log plus another log and it's the same base, you can use the product rule. So that would be log 7 x these two will be multiplied by one another equals to 1, right? So from here, if you simplify it 7, I'm converting it to exponent. X plus 4 multiplied by x minus 2, all right? And then you have to 2x minus 8 equals to 7. You have to solve this quadratic actually. So that would be x squared plus 2x -15, right? So here you're looking for two numbers, add them, you get 2. So multiply your x is either -5 and then +3. These are the two answers. Okay, but what I want you to do whenever you get an answer, you have to go back and check if it's possible or not. So if you put -5, you will see that here it would be -7, which is not possible. So we don't accept this answer. Okay, even here it would make this negative, which is not positive. And we don't accept this answer for this solution. Okay, now the next question is one interesting exponential equation. Here you have an expression raised to the power 0, it's equal to 1. What you have to do here, you have to use your knowledge of math. Okay, so you know that any number, instead of 1, you can just replace it, right?